What is RAG? Retrieval Augmented Generation explained step by step. 1. Opening hook. Hello everyone. Today we are going to understand one of the most powerful concepts in AI, RAG, which stands for Retrieval Augmented Generation. It may sound complex, but it is actually very simple. RAG is used in customer support, healthcare, finance, legal, education, research, and enterprise applications. 2. Simple example. Imagine two students preparing for an exam. Student 1 studies many books before the exam and answers from memory. This is how normal AI models like ChatGPT or Gemini work. They answer based on their training data. Now imagine student 2 also studies, but during the exam, he is allowed to open books and verify facts. This student will give better and more accurate answers. This is exactly how RAG works. 3. What is RAG? RAG is not a single tool. It is a technique that allows an AI model to access external data in real time before answering. So instead of giving only a general answer, the AI can give more accurate answers, more updated answers, more context-aware answers, more business-specific answers. 4. Real-life example. Suppose your flight is delayed. If you ask a normal AI tool, why is my flight delayed, it may give a general answer. But if you ask an airline chatbot connected with your booking data, it can check your PNR, flight number, route, and status. Then it can give a personalized answer. That is the power of RAG. 5. Why RAG is popular? RAG is popular because it solves major problems of AI models. First, it reduces hallucination. AI models sometimes create wrong information confidently. RAG reduces this by grounding answers in real data. Second, it keeps knowledge updated. AI models have knowledge cutoff dates, but RAG can connect them with current data. Third, it is cost-effective. Instead of retraining or fine-tuning the model again and again, we can connect the model with updated documents. Fourth, it improves privacy. The model does not need access to the entire database. It only receives relevant information for the user's question. 6. RAG pipeline. RAG has two main pipelines. A. Ingestion pipeline. This prepares the knowledge base. Step 1. Collect data. Data can come from PDFs, websites, Excel files, documents, databases, or company systems. Step 2. Split data into chunks. Large documents are divided into small parts called chunks. Step 3. Create embeddings. Text is converted into numbers because AI systems understand numbers better than raw text. Step 4. Store embeddings in a vector database. These embeddings are stored in a vector database like FAISS, ChromaDB, Pinecone, or Elasticsearch. 7. Retrieval pipeline. This happens when a user asks a question. Step 1. User asks a query. For example, what are the symptoms of a heart attack? Step 2. Query is converted into embeddings. The question is also converted into numbers. Step 3. Similar documents are retrieved. The vector database finds documents with similar meaning. Step 4. Context is added to the prompt. The retrieved information is added with the user question. Step 5. LLM generates the final answer. Now the AI generates a better, more accurate answer. That is why it is called retrieval plus augmented plus generation. 8. Important technical components. 3 things matter a lot in RAG implementation. 1. Chunking strategy. Fixed size chunking. Text is divided after a fixed number of words or tokens. Hierarchical chunking. Text is divided based on paragraphs, headings, or sections. Semantic chunking. Text is divided based on meaning or topic. 2. Embedding models. Popular embedding models include OpenAI embeddings, Gemini embeddings, Hugging Face sentence transformers. 3. Vector databases. Popular vector databases include FAISS, ChromaDB, Pinecone, Elasticsearch. 9. Popular RAG architectures. 1. Standard RAG. Best for FAQs, simple chatbots, and clean documentation. 2. Hybrid RAG. Combines vector search and keyword search. Best for enterprise search and e-commerce search. 3. RAG with memory stores previous conversation history. Best for customer support assistance. 4. Graph RAG uses knowledge graphs to understand relationships between entities. Best for legal, fraud detection, research, and knowledge-heavy systems. 5. Agentic RAG breaks complex questions into multiple steps and uses tools like web search or APIs. Best for advanced research and analytical systems. 6. Multimodal RAG works with text, images, audio, and video. Best for healthcare, security, and surveillance. 7. Self-reflective RAG first creates a draft answer, then reviews and improves it. Best for regulated industries and research-heavy domains. 10. Closing. So today we understood what RAG is, why RAG is important, how the RAG pipeline works, what vector databases are, what embeddings are, and what popular RAG architectures are used in the industry. RAG is one of the most practical AI concepts used in real-world enterprise applications. If you want to build AI chatbots, enterprise search, healthcare assistance, legal assistance, or intelligent business applications, then RAG is a must-learn concept. Thank you for watching. See you in the next session.